Sorry guys, I just noticed I run out the time, so that's the reason why I pressed the stop button. I try to keep each video clip within 15 minutes, and in our previous section I have almost finished the second experiment introduction. So at the end I mentioned after the second experiment we will achieve following goals. One is we will apply the digital to analog converter, and then we also will apply the push button, and finally we will use the LED tubes to indicate the guide van position. So if we back to I think I have already introduced you the schematic or the working principle behind. So if we back to the experiment board, and so what we're going to do is we're going to apply two push buttons here, which represents those two buttons, increase and decrease. So as long as we press, for instance, we call this as increase button. So as long as we continuously press this button, and because we know this button is connected with one leg of the microcontroller, so the microcontroller will periodically scan that port or that leg. So as long as this data, the status of this button changes, and then the microcontroller will detect that, and then we also will use the RC oscillator, because we have the RC oscillator here. So that RC oscillator just permanently on and generates very high frequency pulse signal. So back to this experiment board, as long as we press this button, and then the microcontroller will start to count the pulse which is generated by the RC oscillator here, and then the microcontroller will pass that information, which is exactly as this schematic indicates, to the digital to analog converter, which is this bit here, and then the output of the digital to analog converter will be applied on this LED diode here. So from our experiment point of view, what we actually can say is, if we continuously press this button, and then we will basically control or adjust the brightness of this LED diode. So if we continuously increasing, and then the diode will become brighter and brighter. If we press the other button, the brightness of this LED will become darker and darker. So that's the and also in the meantime we're going to use the LED tubes to indicate the indication, so which tells you how many percent, well, if we back to the guide van example, so that indication will tells you how many percent of the guide van is opening. Alright, but since we don't have guide van here, so we're going to use a diode to represent the output, or to give you observation about the changes of the analog output. Alright, so that's second experiment, and the third experiment is function generated control. This experiment is the one which I am working on at the moment. And basically the idea is we are going to use a variable voltage signal to control the function generator frequency output. For instance, let's say the variable voltage signal is from 0 to 10 volts, and then we would like to adjust the input voltage within that range, and then based on that input the function generator will give us different frequency output. So it's also called voltage control frequency, VCF. If you search VCF on Google, and then you should find a lot of information about that. There are a lot of different control methods we can apply, but since we have this experiment board and the function generator, so we can do it by ourselves. And this is the working principle. Variable voltage source will go through a analog to digital converter, and the microcontroller will based on the digital input to calculate the I probably need to give you a little bit introduction about the function generator first, otherwise it doesn't make sense here. Alright, let's back to the video. So I have already set up this function generator here. So basically, as you can see, this is the function generator. It's a very small component, so it's pretty much just half for my hand. And currently the function generator gives us functions sine wave with 50.2 Hz frequency output, and also you can see on the oscilloscope, it's a sine wave, nice sine wave, and the frequency is 50.2, 50.3 Hz. So it is very accurate. So if we adjust this button here, this button is called the coding switch. So it's not a variable resistor, it has 3 pins, and basically that switch will generate different code and issue that code into the microcontroller of this function generator, and the microcontroller will based on that code to change the frequency output. So if we now it's 50.1 Hz, 49.98, 49.6. So also you can see the corresponding changes here, and we can move. So currently I don't know if you can see the underscore here, which is underneath so fine, so we can move or shift that underscore to the last bit, so which is in 0.01 Hz, so we can change that. So right now if we tune in the coding switch, you can see the frequency can be changed in very fine resolution. Now if you back to the oscilloscope, you should be able to say now it's 49.68, but now here it's 49.69. So it is very accurate, the output of this function generator. So how can we achieve the control purpose by using the experiment board? Well, apart from use this coding switch here, we also can use those four pins here. So that 4 pin is designed to connect with the external circuit, and well, based on the design of this function generator, this generator or the microcontroller has been designed can be used to receive the external commands, so which is through those 4 pins. So based on that commands, and also we can control the frequency output, not just using the coding switch, and also we can use the sorry, the oscilloscope just to alright, now so the question is how can I achieve the control purpose to control the frequency by using those 4 pins. Basically what I'm thinking is I will use the our experiment board to try to detect the analog input, and then I'm going to use the analog to digital converter on the experiment board to try to convert the analog signal into a digital signal, and then we will use the microcontroller to let's back to the now I think it will make sense if we back to our nodes. So we're going to apply the analog to digital converter on our experiment board, and then I will use the microcontroller to control the command, basically, because well, based on the different input, and then we will going to issue the different command to the frequency to the function generator, and then based on the command, the function generator will give us different frequency output. So that's the basic idea, and also I did a little bit calculation, so I can show you my calculation. Alright. So let's suppose our input voltage is from 0 to 10 volts, and then what we would like to control is the frequency. It's too bright. That's better. So what we would like to control is the frequency output. Let's assume the frequency is sine, and the frequency range is controlled from 47.5 Hz to 52.5 Hz. So based on the hardware we have 8 bits analog to digital converter, and which gives us 256 steps, right? Because we have 8 bits. 2 parts of 8 give us 256 steps. Okay, and so in other words, the minimal resolution of the 10 or 0 to 10 volts input variable voltage is, we use 10 volts divided by 256, so it's 0.03906 volts. So that's a minimal resolution. So in other words, if the voltage is above that value, and then the analog to digital converter can detect it. If the varies or the change is too small, and then the analog to digital converter can't say that. Alright, for instance, if the value, or if the analog input is from 0 to 0.03906, and then correspondingly the converter will give us that value. Because I said it's 8 bits, right? So correspondingly that's 1, and then if the input analog value is between 0. the minimal resolution value to 2 times of that value, which is from this value to this value, and correspondingly the converter will give us this output, which is corresponding to 2, and etc. etc. So the idea is eventually we're going to try to use or our internal logic probably will try to build up matrix. So eventually that matrix has 256 values, and so the first value will give us 70.5 Hz output, or that command, sorry, I should say command, not value, because as I mentioned before, the function generator is command based. So we're going to set the first in the first place, the command will give us 47.5 Hz. So if we keep going, the command which is located in 128 will give us 50 Hz output, and then the command which is located at 256 will give us 52.5 Hz output. So eventually what we're going to do is, we know that's the analog input, we applied on the AD converter, we know that that's the input in the microcontroller, and then we're going to use or you can call it as a lookup table or whatever. So as long as that is 1, so we're going to select the first command. So if the analog input is that value, and then correspondingly microcontroller will recognize it's 2, and then we're going to call the second command, and etc. etc. So I think that's the idea, and eventually go back to our original target, and then we can achieve by using 0 volts to 10 volts variable input voltage, and then to control the output sine wave frequency from 47.5 Hz to 52.5 Hz. So that's the idea. I think based on the information I obtained from the manufacturer, it says the minimal resolution of the function generator, as also I showed you before, is 0.01 Hz, right? And based on our expectation from 47.5 to 52.5, the variation will be 5 Hz. So if we use 5 Hz divided by 0.01 Hz, and then eventually it will give us 500 steps, but based on our analog to digital converter, it just gave us 256 steps. So in other words, each individual step, no matter it's increasing or decreasing, the function generator should give us a corresponding value, because the resolution of the function generator, or the frequency resolution of the function generator, is much larger than the analog to digital converters resolution. So theoretically this idea should work, but we need a little bit work to do. Okay, so that's the, if we back to our notes, that's the idea about all those 3 experiments, and pretty much done the first 2, and the third one is the one I'm working on, and finger crossed. Alright, thanks guys, that's this section.
I will come back soon. See you later.